A projectile is launched horizontally at 200 meters per second from a 50-meter high cliff. First, let's draw the diagram of this problem. As we can see, the initial velocity is 200 meters per second in the x direction. This means that initially there is no y velocity. As the object falls, it picks up speed in the y direction, but it continues moving forward at 200 meters per second. The first thing we're asked to calculate is the time in air. The height at which this falls determines how long it's in the air. First, let's list what we know in the y direction of motion. We know that it falls negative 50 meters. We know that it starts from rest. And we know that gravity is negative 9.8 meters per second squared. We're looking for the time that it's in the air. The appropriate motion equation to use is delta y equals VIT plus 1/2 GT squared. Plugging in what we know, negative 50 meters equals VI times T, which is 0, plus 1/2 of negative 9.8 meters per second squared times time squared. Time squared will be equal to negative 50 meters divided by negative 4.9 meters per second squared. Time will be equal to the square root of 10.2 seconds squared, or 3.2 seconds. So the time in the air is 3.2 seconds. The next thing we're asked to do is to find how far it falls from the edge of the cliff. This quantity is the range. The range is equal to the horizontal velocity times time. In this case, the horizontal velocity is the initial speed of the object, 200 meters per second, times the time, 3.2 seconds, gives us a range of 639 meters. The last thing we're asked to calculate is the velocity of the object just before impact. By the time this thing reaches the ground, right before impact, it's moving horizontally at 200 meters per second. And after 3.2 seconds, it has obtained some final vertical velocity. The vector sum of Vx plus Vy just before impact will give us the impact velocity V. That means that we'll need to use Pythagorean theorem to calculate V, where V squared is equal to Vx squared plus Vy squared. So the first thing we need to do is calculate the final y velocity just before impact. So in the y direction, let's summarize. Delta y is negative 50 meters because we're falling. G is negative 9.8 meters per second squared. It starts with an initial y velocity of 0, and we're looking for the final y velocity. The appropriate equation to use is Vf squared equals Vi squared plus 2g delta y. Let's substitute in. Vf squared is going to be equal to 0 plus 2 times negative 9.8 meters per second squared times negative 50 meters. Vf is going to be equal to the square root of 980 meters squared all over second squared. This will give us either a plus or minus square root of 31.3 meters per second. Since we are moving down, the final y velocity is negative 31.3 meters per second. Now, let's calculate the final impact velocity. V squared is equal to Vx squared plus Vy squared. V is going to be equal to the square root of 200 meters per second squared plus negative 31.3 meters per second squared. V is equal to 202 meters per second. We do not need to indicate positive or negative because this is a vector at an angle. If we wanted the direction, we would need to find tan theta to find that direction that it hits below the horizontal. Since the question is asking for the magnitude of the velocity, we're fine.